What happens when humanity tries to forcefully dissect a piece of alien technology? In 1951, deep inside a classified Oak Ridge vault, 5 top-tier physicists found out the hard way. They didn't trigger an explosion. They triggered a localized frequency that shattered every vacuum tube in the room and instantly wiped their short-term memories. This wasn't a mechanical failure. It was the metal actively defending itself. Welcome to the Shadow Ledger. Today, we pry open the buried files on the metamaterial that proved we are completely outmatched. To understand what transpired in the hills of Tennessee during the early years of the Cold War, one must look past the public-facing history of the atomic age. Oak Ridge was a city born of secrets, built in frantic haste to refine the uranium that ended the Second World War. By the 1950s, its massive gaseous diffusion plants and highly specialized laboratories were the vanguard of American scientific dominance. But behind the triple fence perimeters and armed patrols, a select group of researchers under the United States Atomic Energy Commission was handed a project that had nothing to do with nuclear weaponry. They were given a remnant. The specimen arrived in a pressurized steel container escorted by military personnel who refused to state its origin, though the whispers of a recovery operation in the deserts of New Mexico a few years prior hung heavily in the air. To the naked eye, the object was unimpressive. It was a thin, silvery gray sliver, lightweight and metallic, with a faint iridescent sheen that seemed to shift color depending on the angle of the light. It looked like a fragment of an ordinary turbine blade, or perhaps a piece of aircraft shielding. But the preliminary non-destructive tests quickly shattered any illusions of simplicity. Under spectrographic analysis, the material revealed a composition that defied the established rules of mid-century metallurgy. It was not an alloy. Instead, it was a highly ordered, repeating sandwich of 2 distinct elements: magnesium isotope 24 and bismuth isotope 209. On its own, bismuth is a dense, brittle metal with unusual electromagnetic properties, boasting the strongest natural diamagnetism of any metal on the periodic table. Magnesium, conversely, is exceptionally light and structural. But these 2 elements did not simply coexist in a random mixture. When the Oak Ridge team examined the edge of the specimen under their most advanced optical instruments, they realized they were looking at something far beyond their manufacturing capabilities. The layers were arranged with mathematical perfection. A layer of pure bismuth, measuring only a few nanometers in thickness, was fused to a layer of pure magnesium of similar atomic scale. This pattern repeated thousands of times throughout the depth of the sample. In 1951, the concept of nanotechnology did not exist. The tools required to deposit materials atom by atom, such as chemical vapor deposition or molecular beam epitaxy, were decades away from being conceptualized, let alone built. To the scientists, this structure was as impossible as finding a computer microchip inside a Roman tomb. It was a physical contradiction, a material manufactured at the atomic level, yet possessing macro-scale physical dimensions. The question that consumed the leadership at Oak Ridge was not just how the material was made, but why. What purpose did this precise alternating structure of a highly diamagnetic heavy metal and a lightweight structural metal serve? Some theorized it was a structural component designed to withstand extreme thermal stress. Others, looking at the electromagnetic properties of bismuth, hypothesized it was a waveguide, a highly specialized medium designed to manipulate electromagnetic fields, or perhaps even gravitational waves, at a microscopic level. To unlock its secrets, they needed a closer look. They needed to slice a cross-section of the specimen to examine the crystal boundary layers under an electron beam. The task was assigned to a specialized team working deep within the reinforced concrete bunkers of Sector 4. They constructed a custom apparatus designed to focus a high-intensity, high-voltage particle stream onto a specific point of the sample. The goal was to use the sheer kinetic energy of the accelerated electrons to microscopically shear a fraction of a millimeter from the edge, creating a clean cut that could be analyzed without introducing foreign contaminants. The equipment was state-of-the-art, utilizing massive banks of vacuum tubes to regulate the immense electrical currents required to generate and guide the beam. On the night of the experiment, the atmosphere inside the control room was tense. The air smelled of ozone and hot electronics. The lead metallurgist, a veteran of the Manhattan Project, initiated the sequence. The massive generators hummed to life, vibrating through the concrete floor. Through a lead glass viewing window, the team watched the sample chamber. The electron gun began its steady buildup, a low whistle rising in pitch as the voltage climbed toward its target threshold. At 80% power, the focused emission struck the surface of the specimen. What should have been a routine, albeit highly energetic, physical interaction instantly warped into an anomalous event. The material did not melt. It did not vaporize. It did not even heat up. Instead, the moment the high-voltage stream made contact, the specimen began to vibrate. But this was not a physical shaking visible to the eye. It was an acoustic phenomenon of unprecedented intensity, operating at a frequency far beyond the range of human hearing, yet physically tangible in its effects. The first casualty was the instrumentation. The high-frequency resonance emitted by the specimen bypassed the physical air, traveling instead through the very structure of the building and the electrical grid. Within a microsecond, the intense vibrational energy overwhelmed the glass envelopes of every vacuum tube in the room. The vacuum inside the tubes collapsed as the glass shattered outward in uniform concentric rings. The oscilloscope screens went dark, the dials spun wildly before snapping off their pins, and the primary power relays melted in a shower of blue sparks. But the physical destruction of the machinery was nothing compared to the impact on the human observers. While the frequency was technically ultrasonic, it interacted directly with the delicate fluid of the inner ear and the neural pathways of the human brain. The researchers did not experience pain in the traditional sense. Instead, they described a profound, instantaneous dissolution of their sensory reality. For several agonizing minutes, the physical world became completely disconnected from their perception. One scientist later reported that he could see the sound as a series of geometric dark patterns undulating through the air, while his vision of the physical room faded into a featureless gray fog. Another found himself unable to locate his own limbs, experiencing a complete suspension of proprioception, as if his physical body had ceased to occupy space. The passage of time seemed to stretch infinitely. Seconds felt like hours of quiet, isolated suspension. Their minds were fully conscious, yet entirely severed from the sensory inputs that ground a human being in reality. It was a state of acute, non-physical disorientation, a temporary breakdown of the cognitive systems that translate physical stimuli into thought. When the backup diesel generators finally kicked in, cutting the primary electrical feed to the electron gun, the resonance ceased. The silence that returned to Sector 4 was heavy and suffocating. The researchers slowly regained their senses, collapsing onto the glass-strewn floor, gasping for air as if they had just been pulled from the depths of a dark ocean. It took hours for them to regain the ability to speak coherently, and days for their spatial coordination to return to normal. The incident was immediately classified under the highest level of national security. The damaged laboratory was stripped bare, the shattered vacuum tubes swept away, and the records of the experiment were locked in a vault that required joint clearance from the highest levels of the military and scientific establishments. The specimen itself was returned to its pressurized container and moved to an undisclosed facility, never to be subjected to high-energy beam testing again. The failure at Oak Ridge was not merely a mechanical breakdown or a miscalculation of electrical loads. It was a confrontation with a fundamental truth that modern science was not prepared to accept. The material was not just a structural element, it was a passive yet highly reactive energetic system. When subjected to the intense kinetic energy, The alternating layers of bismuth and magnesium had acted as a perfect resonant transducer, converting the electrical energy of the beam into a localized acoustic and electromagnetic field of immense density. It was a defense mechanism of sorts, or perhaps simply the natural, unshielded reaction of a technology designed to operate in an environment entirely different from our own. To understand why this is so profound, we must look at the physics of bismuth and magnesium. In modern materials science, researchers have begun to experiment with what are known as metamaterials. These are artificial structures engineered to have properties that are not found in naturally occurring materials. They can bend light around objects, redirect acoustic energy, or manipulate electromagnetic waves in ways that seem to violate standard physics. The Oak Ridge specimen was a perfect metamaterial, created at a time when humanity had barely mastered the assembly line. The isotopic purity of the magnesium-24 defied nature. It wasn't forged, it was assembled atom by atom, decades before human science even had a word for nanotechnology. The scientists realized that they were like medieval blacksmiths attempting to analyze a modern titanium alloy with a hammer and a forge. The tools of the mid-20th century were simply too crude, too violent, to interact with a technology that operated on the level of quantum resonance and atomic alignment. By hitting the sample with a high-intensity electron beam, they had essentially struck a tuning fork of cosmic proportions, and the resulting ring had nearly shattered their minds. In the years that followed, the men who sat in that room on that November night carried a quiet, unspoken burden. They had peered across a vast technological chasm and realized that humanity was not at the top of the evolutionary or technological ladder. They were merely children playing with matches near a highly sophisticated engine. The official reports filed away in the archives of the Atomic Energy Commission referred to the event as a high-voltage equipment failure due to transient electrical feedback. But those who were there knew the truth. They knew that the machine had not failed. It had responded. Today, the document detailing the Oak Ridge experiment has been partially declassified. Yet the true nature of the material and its current location remains shrouded in mystery. Was this specimen indeed a fragment of an advanced, non-human technology designed to manipulate the fundamental forces of the universe? Or was it the result of a highly classified, incredibly advanced human research project that has since been lost to history? The boundaries of our understanding are constantly being pushed, but the events of 1951 suggest that there are some technologies that do not merely wait to be understood. They demand a level of consciousness we have yet to achieve. Oak Ridge taught the military establishment a terrifying lesson. We are merely primates throwing rocks at a quantum fortress. The bismuth-magnesium architecture wasn't just a structural anomaly. It was a conscious frequency. If a microscopic fragment can dismantle the human mind in seconds, what happens if we ever uncover the main craft? The government welded those vault doors shut, but the truth always leaks. Do you think we've reverse engineered this tech today? Or is it still sitting in the dark, waiting? Leave your theories below. Question the narrative and stay in the shadows.